Solving trig equations using our favorite things. Inverses. So let's do a warm-up. Here is a function. Find the inverse. Do you remember how to find inverses? If you don't remember, go back to 5.6. 5.6 was finding inverses. And we also did it in another chapter that I forgot which one it was in. But 5.6 is all about finding inverses. I gotta swap two things. Yep. Swap them. If you get done with one, work on two. What?
Sine, I think you do the inverse of sine, which is the negative. Remember the sine -1. Oh, yeah.
Inverse is just opposite.
Inverse is like the -1. Wait, inverse. Wait. It's in a different book. This book starts at like nine something.
You're in the right.
But they're so close. Don't do this.
No, I am. We should. Before you do this, just swap it. Y. X there and Y there.
Oh, is that what you do?
You're not.
Okay.
You're like you're close. This much stronger.
Oh, you solved for what?
I'm just switching X and Y right now.
I think I know what to do.
Ronaldo, what did you get?
Was I supposed to solve or just make it? Because I just did
Like-
X equals 2Y plus 1. If that's even correct. Because I just switched the function.
Okay,
But is that right?
I don't know. I haven't done it yet.
Right.
Okay, switch X and Y. So it's X equals 2Y plus 5. So I should have gone Y equals X minus 5 over 2. This should just be refresher. Do I need to go slow it and show each step?
Yeah.
I heard yes. Okay, flip the X and Y. I want to solve for Y. How do I get Y all by itself? Would have to move over. Minus 5. Minus 5, minus 5. So I have X minus 5 equals 2Y. Amy, what do I have to do next to get Y all by itself? Divide by 2. Divide by 2. So now I have Y equals X minus 5 over 2. So this is my inverse function. Okay, that's regular ones. That's what we did in 5.6. Now we're making them trig equations. And we are trying to find the inverse. I'm going to scooch down. Y equals sine of 2x. Landon, how do I start an inverse if I want to try to find the inverse? I should always do what first? Switch which X and Y. Yep, X and Y. So if I do that, I now have X equals sine of 2Y. Gotta get Y all by itself. We gotta think back to geometry now. Someone said something. I have no clue who it was. What? Okay, Ronaldo said sine of -1. Also known as what? Inverse of sine. Do you remember inverse of sine? It looks something like this. It's the undo operation of sine. So if I took x squared and I want to get x all by itself, what should I do to it? Square root. It's the same thing for sine. If I do sine of x and I take the inverse sine of x, inverse of sine, I should just get x out. It's the inverse operation. Okay. That is just work on the side. So, inverse. I have to do it to both sides. So I have the inverse of sine of x equals inverse of sine times sine of 2x. Kenny, what happens to these two signs? They cancel out. Like so. What's left over? 2y. Shelly, what do I do next? Divide by 2. Divide by 2. So I get y equals what? Liam, what do I get? Sine? Inverse of sine. Don't say sine of -1. Inverse of sine. Inverse of sine over 2. That is my inverse function. That is our inverse function. Any questions about the whole inverse of sine? We're doing the inverse of sine. So if I have sine of x, the inverse of this one is inverse sine. So the two inverses cancel. The inverse of sine and sine cancel each other out because the undo operation, we're just left with x left. Yep, whatever's inside our argument. So in our case, it was 2y. So 2y is left over. Yeah. Okay. I'm giving you another one to try on your own. 2. I don't know which one this is. Y equals, let's do 1/4 cosine of 4x. Find the inverse. Function. I don't know, but I want you to solve for y. Okay.
Because I lost it. I mean, I didn't lose it. That's just.
So I did, I switched x and y, and I inverse of cosine, and you got on the other side you got 1/4 times 4y.
Okay.
I think you just multiply it, as I did. 1/4 becomes 1, and then
Okay,
1/4
so
y.
It's not like
And you multiply 4.
this would be
So it'd be
1/4 inverse cosine.
cosine. I think it'd be y inverse cosine x. 4. No, or 4 inverse cosine. 4 inverse cosine. Really?
I got just. What'd you get?
It's really nothing.
You don't know?
And you multiply 4 on both sides. So I got 4 inverse cosine x. Gee, what'd you get?
What'd you get?
I got cosine of, inverse of cosine of x equals y. Or y equals x.
Because you get the
Yeah. Did you get that?
What'd you get?
I got y equals cosine, or inverse of cosine of x.
I got 4. I got y. 4 inverse cosine x.
Y though.
Raj, look. What'd you get?
Y equals inverse of cosine of x.
Amy, what is my first step always in finding an inverse?
Oh, that's what it's implying.
Switch x and y. So we get x equals 1/2 cosine of 4y. Elijah, what do I do next? So close. I want to get rid of 1/4 first. Multiply by 4. Multiply by 4. So I get 4x equals cosine of 4y. Now what do I do, Elijah? Now inverse cosine. So cosine inverse of 4x equals cosine inverse of cosine of 4y. Yeah, I gotta do to both sides. What I do to one side must do to the other. Because then what happens to, what is inverse of cosine of cosine?
Oh no, I usually skip that part, but yeah.
Okay. What did you skip? What did it equal?
I didn't put the inverse cosine times cosine for y.
It's okay. I normally wouldn't either.
Okay.
Okay. What did we get? Start with the left side.
What's that?
I got inverse cosine of 4x equals 4y.
Equals 4y. Perfect. What? Okay. Sebastian, I have to get y all by itself. What do I have to do to this equation? Say it again. Divide by 4. So divide by 4, divide by 4. I should have gotten y equals, I'm going to put the 1/2 out front. You can put it under the entire fraction. That's also fine. So 1/2 inverse of cosine of 4x. That should be our inverse function. Or you could have written it as cosine inverse of 4x over 4. That's also fine. What's cosine? The 4's don't cross out. Because one is inside parentheses, so I can't do anything with that. 4's do not cross out. Okay. Okay. I want you to sketch 2 images on your sheet. Sketch sine and sketch cosine. That's it. Just the curve.
Wait, you should keep it as inverse cosine.
Which one? Equals 4.
You want to keep it inverse cosine.
Yeah, you can keep it over 4 or do you?
Either one is fine. Either one is perfectly fine, yeah. Okay. Graph sine and graph cosine. State its domain and range from the unit circle. I want you to graph sine and cosine are parent functions, which we got from the unit circle. What do they look like? You should know this from the test. This is a good check to see if you graph the right function. Yep, graph cosine and sine. You good, Landon?
Just about maybe the last.
Okay. And then state their domain and range, given that they are the parent functions from the unit circle. Just sine and cosine. And you can do tangent if you want. Good, okay. Okay, what does sine look like? Starts from the origin, goes up, down, keeps going forever, also in the other direction. Put the other direction as well. What is its max height? If I'm from the unit circle? 1. What's its lowest? -1. What's its x value at its max? What is its x value, or theta, at its max height? So up here. I'm at 1. So when sine is 1, where am I at in the unit circle? Pi halves. Yep, pi halves. Okay. Negative direction. I'm over here. What radians am I at? Negative pi halves. Negative pi halves. Okay, let's do cosine. Where does cosine start, Angel? 1. Give me a point. Give me an actual coordinate. 0, 1. So we are up top here. We curve down, then up, then down, then up, like so. And on the other side. Sunny, what's its max? What's its lowest point?
-1.
Yep. Let's do what? It's at 0 radians here, right? How many radians are we right there? Pi halves, because that's where it's 0. What about right here? What is... Yep. So that's how we were trying to find cosine at -1. We would be at pi radians. Yeah. We're going to graph the inverses of these next. So y equals sine inverse, and y equals cosine inverse as well. No. That's their reciprocals. Inverses and reciprocals are different. Very true. What? They're not the same. Not at all. Okay, looking at sine. Does sine pass the vertical line test? Who knows the vertical line test? Michael, what's the vertical line test? Yep, so if I go this way, we only have one x value for every y value. So it passes vertical line test. What about horizontal line test? Horizontal line test. Talia, what's the horizontal line test? Yeah, going this way. I have just touched 1, 2, 3, 4, 5, 6 points. That is not a function. But our inverse, we have to switch the domain and range. So we have to make it. We have to do a restriction on this curve. Where can I restrict the domain so that does pass the horizontal line test? Michael says 0. To where, Michael? I need a range. I need a range of numbers so that my function can pass the horizontal line test. 2 pi? 2 pi is over here. So I go from 0 to 2 pi. I would still be hitting 1, 2, 3, no, 2, technically points. So it doesn't pass the horizontal. Wait, I heard negative pi halves, 2 pi halves. Right here. Amy, does that pass the horizontal line test? If I'm just talking about that range? Yeah, it does. We're going to take that curve and we're going to graph it for the inverse of sine. So inverse of sine. Inverses. I switch x and y. We can also switch what and what of our functions.
Sine, cosine.
No. Thinking back to like y equals 2x plus 5. If I were to graph that, we're flipping over y equals x. I'm switching x and y. I'm also switching our domain and range. Right? Yep. So instead of negative pi halves being in our x, it's now in our y. So up here we're at pi halves. And down here we're at negative pi halves. So what would be over here now on our x-axis? 1. What would be over here? Yep, negative 1. And I'm going to take those same points and make the same curve. Well, not the same curve, but the inverse curve. So we have a point up here, which was this point right there. We have a point at the origin. Where's it going to be on our inverse? We're taking each point, we're putting it over y equals x. So we're just flipping the domain and range, so our x and y values. So am I at the origin? Where am I going to be for my inverse function? The origin. And if I'm at negative pi halves and negative 1, where would I be at my inverse? I heard negative 1. Where's my y value? Yep, negative pi halves. Okay, connect 2 points. What curve are we drawing right now? Graph it. See what you get.
Yeah, but it's a tangent. Well, I guess we haven't finished.
It's just the one.
So good. Love it. Remember when we drew the first cosines and sines and you guys drew like these? And then everybody's first waves were like these. Because it looks like these are going to be a straight line. But there's points missing there.
Oh, so they're already straight lines, or they're just gonna be, or they're gonna look like tangents?
They're going to look like.
Don't think it's gonna look like tangent.
Is it just supposed to be a straight line through, or like?
No, we're talking about circle, so we're still curving.
I mean, like, without the other points, it looks like tangent.
This is Julia's lovely curve. We should be going up to 0 and then curved concave down. Well, not concave down, but
I went
up. So our original sine function went like this and then went up. But now we're flipping it over a line that goes right through both these points. So you're flipping the curve. So it should be going up like that and then down. So make a curve looking like that. Otherwise, it's not. Sorry, Michael. We're gonna use it to solve equations. We're not gonna graph these again. You're just gonna see what they look like graphed. That's about it. We just did a brain break. So it should look like this. That is our function. That is not tangent.
It's not, but it looks. That's inverse of sine.
Okay. What's the domain and range?
Domain, I don't know, negative 1 to 1, range, all real.
Yeah.
What? All real, huh? What, why'd you write all? No.
I don't see arrows.
But what if there were arrows?
There isn't arrows.
Oh,
We're doing the typical sign.
yeah,
There
I have.
is a restriction on my domain and range. What? Restriction. We had a restriction up above. We had a restriction on the domain, which means for the inverse, a restriction on the range.
Why put it all yours?
This is range. Oh, I don't know why I did all these. Range. Range. We have restriction. Negative pi halves, 2 pi halves. That's only where the inverse of sine exists on a graph. What's up, Liam? when y comes back, which she is. Yep. Okay, cosine. You want to do it on your own? Yeah? Okay. Do you want to do it up on the boards? No? Okay, fine. Do it on your own. Got it, Landon? Where is our restriction? If I did the same restriction, I would just have this top curve, and that would not pass the horizontal line test. 0 to pi. Yep. 0 to pi.
Why didn't we do that with this one?
Because if I just did this, I could keep going. It's the max we can go to make the inverse a function. So we would pass the horizontal line test. If I kept going, then it wouldn't pass the horizontal line test. But this is as far as I can go, it does pass. Okay. Graph inverse. Then state the domain and range.
Wait, yabba dabba doo. Where did this start? Wait. Can I go like this? The inverse. Wait, what?
So my restriction is from 0 to pi. So my y-axis now should be what to what?
Why should be pi?
0 to pi.
0 to pi?
0 to pi.
Oh,
Because
not,
that's what we're restricting here.
not negative pi to pi? Oh,
This is our domain. So now it's become a range of the inverse function.
so I don't need that bound.
Domain and range. And so
Wait, so our picture is like sideways?
this right now.
I
So
don't get
domain
it.
or is it domain? Oh, what is it? Domain.
That's what I got.
Yeah.
I circled.
So now we're gonna put that.
So,
This is cosine.
So this is our x.
we're looking
You just
at.
talk.
I'm still trying to graph it.
I'm so, yeah.
Okay.
I think I know how to graph it.
So you went from pi half to pi. It should be. You guys asked to do this by yourselves.
I didn't. I didn't.
Hey, what's
ask
with
you.
Let's do it together.
So like if I do it here, it only restricts from.
Yeah.
I actually came.
Do you guys want to do it together?
Yes.
Okay.
No, you're
Well, y'all wanted to do it by yourselves.
No, I don't want to do it together because it's gonna make it faster.
Okay. Where is my restriction on my domain up there? 0 to pi. When I talk about inverses, my domain and range do what? They switch. So my domain right now is from 0 to pi. My range for my inverse should be inverses. We switch x and y. This is back to 5.6. If we switch x and y, our domain and range flip, Kennedy. If our domain and range flip, we're switching x and y. This is my x from 0 to pi. So my y, my inverse, should be the same thing. So we're going to flip it. Flip the x and y. So we go from 0 to pi up here. So this is 0. This can be pi up here. This would be pi halves. Because that's what's in the middle. So we're taking the x values, putting it to our y values. What? Okay. Okay, what are my y values for cosine in my restriction? 1 and -1. Should that be my x or y axis for my inverse? X axis. So let's put them. -1 and 1. Okay, Kennedy, tell me a point. Any point you want in my restriction right here in this box. In this one. So pi halves? I think we're at, what point is this? 0. Okay, so you want to do pi halves 0. So I switch that. I now have what? So before you said it was pi halves 0. Inverse, we're going to switch the x or y. So now we have 0, pi halves. So we start at 0 and I go up to pi halves. Great, we have 1 point. Naomi, do another point. If I'm at pi, what's my y value? Yep, okay. So we're taking pi, -1. Sunny, what do I do at this point if I want to plot it for my inverse? Switch them. So now I have -1 and pi. Okay, so -1 and pi. There's that point. What's my last point? What point haven't we done in our restriction? That's easy. 0, 1. So I take 0, 1 and I flip it. What should it be? 1, 0. 1, 0 is right there. Can I connect the points? What does our curve look like? Connect the points. What do you mean it's so small? You can write it bigger.
It isn't hurt as bad. Chicken boy. Yeah. Oh, rest of it. Doesn't hurt. It was here since like Monday. Okay, now it kind of hurts. Yeah, it's bad.
You good, Sunny? Oh. Okay, this one we should have curved down. Like below. Oh, that was erasing. Because if I'm switching it, see how it's up? Okay, flip it. So flipping it will look like that. And this one looks like that. So that part right there goes right there. That part right there goes right there. Yep. Okay, do we have this curve? Yeah? Yeah. So much fun, right? Inverse graphing? Okay. I'm going to give you tangent. Inverse of tangent. No. Because we have 4 minutes left. Y equals tangent -1 of x. I want you to try to graph it, and then I'll show you what it looks like. Where are asymptotes of regular old tangent? Asymptotes, up and down, vertical asymptotes. It's negative pi halves and pi halves, right? That's right here, vertical. We're flipping it, now it's horizontal. So start from there.
Oh, it's.
Yep. I give you your vertical asymptotes, now become horizontal asymptotes. Yeah. Okay. It was, Michael told us it was negative pi halves and pi halves. I know it's on purpose because I want you to do it yourself first.
If you can make a table for tangent like normal, like, or if you look back at notes, because I think you might have done it, just swap the order. You'll have the graph already. You've already graphed tangent.
I don't even have my notebook, right?
Yeah.
Why'd you guys sell amusement? Why'd you guys sell amusement?
I want to do something different. have to do another business.
Okay. I think I got. That's what I was thinking. That's what I know.
Yeah.
My mom's just been chilling.
Well, I
so
got.
She sold
Oh,
two businesses.
I see what
the
you
span of what? 3 months.
And now I'm just chilling.
Well, why
But,
just put it down?
I don't know.
But he checked on
Yeah. You do more. If I do the vertical line test, would I pass? Would I pass the vertical line test? You only got one of them. You only want to do one.
So, but is that in like the ratio?
Inflation.
Or is it supposed to go this route?
No, let's go the other.
Oh,
Okay, what's the domain and range of regular tangent? Domain is our x values. Yep, go ahead, Angel. Angel had it. Yeah. So it would be, range would be all wheels. Oh, I'm sorry, I forgot.
You're good.
yes.
Yep, we'll talk about this tomorrow.
All right, today's my last day. I want you guys to know it's been awesome working with you all this year, and thank you for being so welcoming to have a student teacher in. It's been awesome. I look forward to seeing you all in a few weeks. I will be on this big screen showing you Cowway to introduce you guys. But if I don't see you again, feel free to email me. And I want you guys to have a wonderful summer, and I look forward to working with you all in the fall. Most of you all. Cool. Thank you guys.
Want homework? No, I'm just kidding. No homework. Okay.
After that.